Sampling distribution of proportions. In this example, we're going to discuss the sampling distribution of a proportion. We begin with an example. Assume that in an election race between candidate A and candidate B, 0.6 of the voters prefer candidate A. If a random sample of 10 voters were polled, it is unlikely that exactly 60% of them, or 6 out of 10, would prefer candidate A. By chance, the proportion in the sample preferring candidate A could easily be a little lower or a little higher than 0.6. The sampling distribution of P for a sample size of 10 is the distribution of proportions that would result if you repeatedly sampled 10 observations and tallied the proportion that favored candidate A in each sample of 10. The sampling distribution of P is a special case of the sampling distribution of the mean. This table shows a hypothetical random sample of 10 voters. Those who prefer candidate A are given scores of 1, and those who prefer candidate B are given scores of 0. Note that 7 of the voters prefer candidate A, so the sampled proportion P is 7 divided by 10, or 0.7. The distribution of P is closely related to the binomial distribution. The binomial distribution is the distribution of the number of successes, favoring candidate A, for example, whereas the distribution of P is the distribution of the proportion of successes. The binomial distribution has a mean of n times pi, where n is the number of trials and pi is the probability of success on a given trial. For the sampling distribution of P, we divide by n to adjust the fact that we are now dealing with means instead of totals. The mean is pi. The standard deviation of the sampling distribution of P is the standard deviation of the binomial distribution divided by n. Returning to the voter example, mu is 0.6 and therefore the mean of the sampling distribution of P is 0.6. The standard deviation is computed as shown. Note that the sample size n is 10. The sampling distribution of P is approximately normally distributed if n is fairly large and pi is not close to 0 or 1. A conservative rule of thumb is that the approximation is good if both n pi and n times the quantity of 1 minus pi are both greater than 10. The sampling distribution for the voter example is shown here. Note that even though n times 1 minus pi is only 4, the approximation is still quite good. Unlike the normal distribution, the sampling distribution of P is a discrete rather than a continuous distribution. For our example, with an n of 10, it is possible to have a P of 0.5 and a P of 0.6, but not a P of 0.55.